The next rule that we learn is the product rule. So after learning the sum and difference rule, where you just take the derivative of things separately, when you have a product, our gut feeling would be, oh, I would like to just take the derivative of each part separately and then multiply them together. Unfortunately, that doesn't work. In fact, one of the fathers of calculus, Leibniz, also guessed that that would be what would happen first and found out that it failed miserably. If we wanted to see why it fails miserably, we could take a simple example. You know that x to the 5 is the same as x times x to the 4. If you do the derivative over here, you get 5x to the 4. If you did the derivative of each thing separately, I've got to quickly put a red X so you don't think that that's true. If you do the derivative of each thing separately, you can see that it doesn't work. And so he went back and he played around with it a little bit more. And again, one of the things you're going to see in university calculus is a proof of why the product rule works. But after playing around with it a bit, we came up with this not so intuitive rule. And one of the things that we use to help us see what's happening here is some colors. So when we have two functions multiplied together, one function u of x, second function v of x, the derivative always keeps one of them the same and multiplies by the derivative of the other one. Then it keeps the other one the same and multiplies by the derivative of the first one. The order doesn't matter. I tend to keep the first one the same, derivative of the second one, then I keep the second one the same, derivative of the first one. But the order doesn't matter. So the top part where I've highlighted it, that's generally called Newton's notation because it uses function notation. And in Leibniz notation, we have the same thing, two functions u times v. The derivative says keep u the same, multiply by the derivative of the second function, and then keep the second function the same and multiply by the derivative of the first function. So I'd like you to just take a notice, look at the two notations, and can you see, I mean, they're different notations, but can you see how they mean the same thing? Okay? Make a decision which one you like better, if you're indifferent, or if you really dislike them both. Hopefully that's not the case. So now we have an option. When we get a question like this one, our options are, A, is there something algebraically I can change this to use things I've learned in the past, just my power rule and just my sum and difference rule? Or B, should I use my product rule? And both answers should be the same. So using what we used before, I'm going to look at them and I'm going to make the decision which one I think is the easiest, and I'll do that one first. So I think using what we had before, where I distribute this 2x cubed minus x squared and then do my derivative rules from the past, I think that's the easier way in this situation. If I used my product rule, I could go to my derivative right away, and it says keep the first one the same, multiply by the derivative of the second one, plus keep the second one the same, multiply by the derivative of the first one. Now, if I simplify this, I'm going to get 2x squared plus 2x squared minus 2x. What happened? Where did I make a mistake? Oh, it's a 2x squared is 2x, 2x minus 1. What's that? Oh, it's 4x squared. Thank you. I was looking and I was like, what? 2 times 2 is 4. Beautiful. That's good math, right? There it is. It's like, it should work out to the same. Something went wrong somewhere. And so we get the same answer. I think the black technique here is easier using the old method because it wasn't hard to distribute. But depending on your numbers, it might be nicer to use the blue on the right. And sometimes you're not asked to simplify. Although, for all of your questions that you do in your homework, I want you to look at the answer key in the back, and I want you to work at your algebra skills to see, can you simplify it to match the answer in the back? So in this case, you would have to simplify it, and I think the black is an easier route to get the simplified answer rather than the blue. Especially because obviously I can't multiply 2 times 2. And I got the wrong answer as a result of that. All right, for this one, again, I'll do it in both ways. But this time, I think that the product rule might be easier. So the product rule says, keep the first one the same, 3x to the 4 minus 7x, multiply by the derivative of the second one, which is just 2. One of the things sometimes I do is I put, where's my multiplication? I put a dot in there to say, oh, I can see that 3x to the 4 minus 7x is my first function, and 2x minus 1 is my second function. Sometimes I highlight them like I did in the formulas. There's my first function in yellow. Here's my second function in green. So I kept the first one the same, derivative of the second one. Then I keep the second one the same, derivative of my first one. And if I wanted to, I could expand things here. 6x to the 4 minus 14x plus 24x to the 4 minus 14x minus 12x cubed plus 7. And then combine my like terms. 30x to the 4 minus 12x cubed minus 28x plus 7. And hope that I didn't make any algebra mistakes along the way. But I think this one was easier because it didn't have 2 times 2 in it. I could have also done this one by multiplying first. So if I multiplied everything out first, I would get 6x to the 5 minus 3x to the 4 minus 14x squared plus 7x. If I multiplied it out first, then my derivative, 30x to the 4 minus 12x cubed minus 28x plus 7. Actually, when multiplying out, it looks like the black one was easier as far as getting a simplified answer. Okay? Sometimes in my questions I'll say no need to simplify your answer. Then you would just need to do this one line and you'd be done. And you haven't done math like that probably since grade 9, where you just had to write one line and your answer's done. One step. Grade 9 questions had like x plus 7 equals 10. and you just went x equals 3. And you just wrote the answer. And you get to do that again in calculus. Sometimes your answers get really, really long, but you can just write out your answer and be done. And that hasn't happened for a long time. Usually math has been like, okay, do step 1, and then I got to do step 1, 2, and then a bunch of algebra, and then a little bit more. But now we can go directly to the answer right away. If you have to simplify it, then there's the work to be done. So that is where realizing, oh, maybe this strategy would make it quicker to simplify. Find the derivative. So the d dx in front means find the derivative of what's inside. Notation-wise, it's okay then to say dy dx equals, and if I'm going to use the product rule, here I would keep the first one the same times the derivative of the second one plus keep the second one the same times the derivative of the first one. Maybe I make a little note here that this square root of x cubed is equal to x to the 3 over 2. And then, because I've made that note, I can see that the derivative of the first one will be that. Now, if you weren't asked to simplify it, you could just leave your answer like this. If you were asked to simplify it, you'd have to multiply things out and see what the answer is. So I'm going to keep this one just like this. And obviously, if you don't have to simplify it, this is easier using the product rule than it would be to multiply everything out to begin with and then do the derivative.